Oh,
In the digital age, toxic comment pose a threat to online harmony. Using a machine learning, we automate the identification of harmful comment to create the safer online space. This presentation will cover the significance data source, tools, model evolution, challenges, and the future implementation of comment toxicity detection. My name is Preet Patel and my group members are Smith Patel, Utkarsh Patel and Shivam Patel. So here is our problem statement. Comment toxicity detection in machine learning is a crucial task aimed at the identifying and the flagging comments or text that contains offensive, abusive, or harmful content. This task is essential for maintaining a respectful and safe online space, as well as for preventing the spread of hate speech, harassment, and the misinformation. We have used modules like TensorFlow, NumPy, Pandas, and we use a dataset from a Kaggle, which is mentioned here.
Okay, so here is the step two where we do the pre-processing of our data set. So first of all, we'll load our data set, which will contain the comments and their toxic and non-toxic behavior. And we will use Pandas library to handle this data efficiently. Now we will split our data set into 80% and 20% ratio, 80% for the training purpose and 20% for the testing purpose. And below is the given code we use for pre-processing our data. So this is the here we have done the vectorization of our text. Like I hate you, so we'll vectorize this into a numeric form, and we will give input to our model in the form of integer, that is a numerical format. Now here the max tokens has been used to count the maximum number of unique words we have in our data set. That is we are having here 2 lakh words in our data set. And the output mode is consisting of integer type, which will return 0 or 1 as an output. And below is the given code for vectorizing our inputs. So here we import necessary layers like TensorFlow, sequential and embedded layer, LSTM layer, and dense layer. Creating a sequential model, we use sequential API, and and using embedded layer, we convert our integer encoded tokens into the dense vectors of fixed size. And this embedding layer, the input should the input we are giving to the model, it will match the max features and will set the vectorizer. And the output it will determine the size of embedding vectors. So, and now LSTM layer is a recurrent neural network layer which is often used for sequential data like text. And dense layer we finally is a single neuron and a single activation function like sigma which will return 0 or 1, that is toxic behavior or non-toxic behavior.
so here is the code of step 3, that is creating the sequential model. So we need to import the necessary modules. We need to import the sequential model from TensorFlow and Keras, and we need to import the layers, which are LSTM, dropout, bidirectional, dense, and embedding layer from Keras. So here we have instantiated the sequential model, and we have add the multiple layers into that. So first layer is embedding layer, second layer is bidirectional layer. So why we add bidirectional layer? Because sometimes there are some comments that like I don't hate you. So the model will first, if the model is unidirectional, it will just see the word hate and it presumes that it is a negative current, but in actuality it is not. So using bidirectional, we can back propagate and see that the don't, that means it is not a toxic comment. And here we have some dense layers with activation function as ReLU, and the final layer which has activation function as sigmoid, that will give the final output, uh, which have 6 parameters. We will see in the output what are the 6 parameters. And here is the step 4, that is to train our model. So we use the model.fit to train our model, and we have defined the number of epochs, means the iteration, as 1, and the data we have already separated, that is testing data, training data. For this we have passed, and it will take some time to train, but after train we have plot into the graph form. So we can see here the code of graph, and we have prevented the overfitting, so that we have used 80% of our data as a training data and 20% of data as testing data to prevent overfitting.
So the step 5, evaluate model and testing. So after training the model, you can evaluate the model performance on the test set using the evaluation method. This will provide you with matrices such as loss and accuracy, indicating how the model generalizes to unseen data. So we will vectorize the word, and it will the vectorizer converts the word into tokens. So the tokens will be stored into the input stream. The, next, the model will predict the input string, and the result will be stored in the result. And we will then show the result. So, for example, the comment is "I freaking hate you," and the output comes with whether the statement is toxic or not, severe toxic or not, obsessed, threat, insult, identity hate. So it's clear that the sentence is toxic, and insult, and it insults the other person. So the output in insult is true. Similarly, the other options like other outputs shows that it is the whether it's true or false. Thank you.